Hello, I just wanted to record some video solutions for the practice quiz. So let's take a look at this first problem. It says, in the 1980s, it was believed that congenital abnormalities affected about 5% of the nation's children. Some people believe that an increase in the chemicals in the environment has led to an increase in the number of abnormalities. A recent study examines 384 randomly selected children and found that 23 of them showed signs of an abnormality. Does this provide evidence that the risk of congenital abnormalities has increased? Use alpha equal to 0.05 to make your decision. Alright, so the first part, and this is the most important part, says what would the appropriate hypotheses be for this problem? Okay, so before we even begin, let's just make sure that we can recognize that we have one and only one sample here. Okay, we're dealing with proportions, and we have one sample of 384 randomly selected children. So we are dealing in a situation with only one sample, and so our null hypothesis will be in the form of p equal to something. P equal to some number, and then the alternative hypothesis will be identical to that, except p is whatever number this is going to be the same number down here, but we've got a different sign, whether that's not equal, greater than, or less than. Okay, one of those other signs there. So let's take a look here. Here it says we used to believe that it was believed 5%, and we want to know if it has increased. So that's going to designate that our null hypothesis is p is 5% or 0.05. The problem as we read it says, does this provide evidence that the risk of congenital abnormalities has increased? Okay, so increased would indicate that we are now expecting our p, the risk of a congenital abnormality, to be greater than 0.05. So looking at that, the only correct answer choice there would be answer choice B. So number 1 is answer choice B. Let's take a look at problem number 2. What would the standard error be for this problem? Okay, so let's so the standard error for a hypothesis test with one sample, the standard error is equal to the square root of p times 1 minus p divided by n. Or make sure to use the p in the null hypothesis. So in this case, in this case we are going to use p equal to 0.05. Okay, so looking at our problem, it's always good to just kind of label the information that we know. Let me just see. All right. Okay, so looking at our problem, we have 5% here. This is going to be our p, or our p0 in our null hypothesis. We have this number 384. This is our n, and 23 is our y. Okay, and so we should also note that p hat is going to equal y over n, so that's going to be 23 over 384. And I can punch this into the calculator and we can work with that in a moment here. Okay, but anyway, we're dealing with p, and so p in our null hypothesis is 0.05. So my standard error is going to be 0.05 times 1 minus 0.05, which I can do in my head to say is 0.95, or you can do 1 minus 0.05, divided by n, which in our problem is 384. So I'm going to punch this into my calculator. I'm going to have 0.05 times 0.95 divided by 384. Okay, I get this number, 0.00012369791. I'm just going to hit the square root and the answer key. And I do equals, and I get 0.0111. 0.0111219 5651. Okay, I'm going to just leave it, and so looking at our answer choices, I've got answer choice A, 0.01111, okay, or 0.0111. Okay, I don't know what this is saying over here, but just go with the answer choices that are listed. There's 4, it's rounded off to 4 decimal places, so this rounded off to 4 decimal places would be 0.0111. Now, I generally leave these answers in the calculator so that the next part of my question, I don't have to do any retyping it, and let me show you what I mean. So number 2 is answer choice A. What is the resulting test statistic? Okay, so the test statistic is given by z equal to p hat minus p, or p0, the one from our null hypothesis, divided by our standard error. Now we saw that p hat is going to be y over n, 23 over 384. So I'm going to actually not even bother turning it into a decimal. I'm going to leave it as a fraction. 23 over 384 minus the p0 from our null hypothesis is 0.05. And I'm going to divide by my standard error, which is 0.0111,219,5651, etc., etc., etc. Okay. Now, to save myself from typing in a bunch of numbers, notice that in my calculator I still have this in the screen as the current answer. And so I'm going to take the numerator, I'm going to calculate that out by doing 23 divided by 384. And my calculator can handle order of operations, so I'm going to just leave that as such. And I'm going to subtract off 0.05 and close off the parentheses. And that way I have the top portion of the calculation already in there. And then I'm going to just hit divide and hit answer, okay? Because then this whole number right here is going to be put in here, and I don't have to bother typing in all 8 or 9 digits or however many digits there are here. And I'm going to hit equals, and this is going to be my test statistic. I'm going to get 0.889755, okay? 756521. Okay, so I bothered copying all of these down. Now, because we're going to look this up in the z table, I'm going to have to round this off to 2 decimal places, because to look up in the z table, round to 2 decimals. So I'm going to have z equal to 0.89. Let's take a look. And so our test statistic is answer choice C, 0.89, because we're going to have to look that up in the z table. And what is the resulting p-value? So now I'm going to look up 0.89 in the table, and I have to decide whether I want the area to the right, left, or the tail areas times 2. Notice my alternative hypothesis has a greater than sign, okay? So when my alternative hypothesis has a greater than sign, I'm going to take the area to the right. Okay, so I'm going to go to the z table, look up 0.89, and I want the area to the right over there. So looking at my z table, I go to z equal to 0.89, and I find the area to the left is 0.8133. So this part is 0.8133, which means the area over here is going to be 1 minus 0.8133. Okay, so let's do 1 minus 0.8133, and I get 0.1867. So my tail area over here is equal to 0.1867. And so the answer choice there is answer choice B, 0.1867. So what is the appropriate conclusion? So we're going to take our p-value and compare it to alpha. Alpha is 0.05. Okay, and so at this point, our alpha is 0.05, and our tail area, or our p-value, is 0.1867. So we see that 0.1867 is greater than our alpha. So let me just put this over here. 0.1867 is greater than alpha, so that means we do not reject the null hypothesis. Okay, so that's going to be the first part of our answer. It says Okay, well, let's go through here. The p-value is smaller than alpha, that is wrong. Our p-value is greater than alpha, okay? So the p-value is greater than alpha, the p-value is greater, so C, D, and E are acceptable answer choices. And whenever your p-value is greater than alpha, we do not reject the null. So let's take a look here, okay? So we do not reject the null, so that eliminates answer choice E. Okay, and so let's see what this says. So we do not reject the null. P-value is greater than alpha, we do not reject the null. C and D look good so far. And the last one says, this provides evidence that the risk of congenital abnormalities has increased. And the other one says, this does not provide evidence that the risk of congenital abnormalities has increased. Wow, okay, so this, we have to think back to our problem and decide what we have. Remember, our hypothesis is answer choice B. Okay, so our null hypothesis was that P equals 0.05, and our alternative is that P is greater than 0.05. And so our question is, does this provide evidence that the risk of congenital abnormalities has increased? So the null basically says no increase, and the alternative states that it has increased. So when we look at our answer choices, we did not reject the null. So we didn't reject the idea that there was no increase. Okay, so let me state that again. We did not reject the idea that there was no increase. So it doesn't prove that there's no increase, but it means that we don't have evidence to say that there has been an increase. Okay, we don't have evidence to reject this. So our conclusion is going to be answer choice D. This does not provide evidence that the risk of congenital abnormalities has increased. Okay, so we are not concluding the alternative. We are not rejecting the null. So we are saying we do not reject the null, and this does not provide evidence that the risk of congenital abnormalities has increased. I hope this has been helpful for the first side of the practice quiz.